Okay, we're looking at a new unit called quadratic functions, and we're going to investigate these quadratic functions. That's what we're going to try to do. But before we do anything, we have to remember, what does the word function mean? Well, hey, grade 10 definition. It says function. Each element of the domain, the x, is related to exactly one element of the range, which is called the y. You remember this from last year. For every x, there was only one y. Now, probably the best way of describing this is using those nice little egg diagrams, right? Where you had a whole bunch of elements here in the x and a whole bunch of elements here in the y. And we said, okay, that guy goes to this guy and that goes to that and that maps to that and so on. You remember that, right? We could even have this guy mapping to the same y, right? That's all allowed. That's called a function. The most important thing to look for is when you look in this egg diagram over here, that you'll notice that each one of these x's only has one stem coming from it. Okay, so one start. They don't have doubles. So that brings us to things that are not functions. Things that are not functions would be something that looks like this. We have a whole bunch of elements here, a whole bunch of elements here, and you have this guy going to this guy, and the same guy going to a second one. Okay, that's an x going to two values of y. That's not allowed. So, okay, now we know what a function is. We also used something called functional notation. Now, I don't know if you remember this or not, but hey, why not? There it is. Do you remember? F of x, right? And it's read f of x. What does that mean? F of x just replaces the y. So if you look at an equation like this one right here, okay, and this one right here, they're the same equation. This just says y equals to 4x minus 5. This says f of x equals to 4x minus 5. And we can do something like this, a simple substitution. We can say, well, let's find the value of y when x equals to 2. So all you got to do is substitute the 2 in wherever the x is. Da-da-da, right? You got 4 times 2 minus 5. 4 times 2 is 8. Minus 5, that works out to be a whole rockin' 3, right? Okay, watch what happens when we have functional notation now. In functional notation, that x is replaced by 2. So we say f of 2. That's what we say, f of 2 instead of f of x. But one of the things that I want to point out here is this. Wherever the x was, it's now replaced by 2. What happens then? Well, look, 4 times 2 is still 8. Minus 5, you still get the same answer as over here. It's just a different way of looking at this. And remember, functional notation ended up doing a whole bunch of cool stuff for us. That ended up making something called a function machine and all kinds of crazy stuff. You know what? It doesn't matter. Just always remember that this f of 2 means replace all the x's by 2. Even if we had something really weird, like, 2x plus 5x plus 3, and that's your function right there, okay? So even if I put in an f of 2 here, that means every x is replaced by 2. So this would be 2 times 2 plus 5 times 2 plus 3. That's all it means. And then you could just, combine like terms and everything's happy, right? Giving you 17, right? That's all that f of x function notation means, okay? Why do we use it then? Because the word f of x tells you that this guy is in fact a function, which means for every x, there is only one y. That's why we use it, because it identifies the function. Now, okay. Now that we got all that grade 10 stuff out of the way, let's go on to this. Now, what is a quadratic function? Okay, here are 2 different ways of looking at a quadratic function. One is going to be called the standard form. And standard form is very, very important because this is functional notation. So yes, a quadratic is a function. And this is called vertex form, which is, again, a function, but just a different way of looking at the same thing. See what I mean? It's just a different way of looking at it, all right? Now, what does this mean? Okay, you're going to have things up front. Do you remember what those things are called? Yeah, those are called coefficients. right? Those are called coefficients, right? Those coefficients up front are usually numbers. The numbers could be anything, could be decimals, could be fractions, could be big numbers, could be small numbers, who cares? The most important thing is this A here, you'll notice, cannot be 0. Okay, now you'll notice another thing here. Notice that this X has a square on it. Yeah, so in fact, those x's are always squared. Notice this one, even though the squared is here, remember, you're going to have to FOIL this, and this ends up giving you a square in the x as well. So that's what makes a quadratic a quadratic. You have to look for an x squared somewhere in that nice little formula. Okay, so now that we know what a quadratic is, great. Let's go on and start playing around with this and see what we can do. Oh, one last little note that I want to put down here. Ba-da-da-da. All quadratics have a degree of 2. So in other words, look for an x squared. No x cubes, no x to the halves, no x ijamas, okay? They're all squared. Okay, so done. Let's go. Boom. I'm going to show you the easiest one in the world. Here's a quadratic, the easiest quadratic. No extra, C values and B values and nothing. This is just a plain old simple quadratic. And I want to go out and look at this and start graphing this guy here. So, okay, y equals to x squared. We can actually write it as a function if you want. And there's the functional notation for that guy. But what we're going to do is we're going to develop a table of values for it. What do I mean by that? Well, here's a table right here that I've just got written for you. We're going to take every one of these and we're going to substitute it into the equation. So we're going to do f of 0, f of -1, f of -2, and f of -3. And the same thing going the other way as well. We're going to do f of 1, f of 2, f of 3. Holy smokes, look at all the great stuff that we're going to do. So remember what the equation is. The equation was f of x equals to x squared, okay? So let's start substituting in some values here and let's see what we get. The best one to substitute in is this guy. I love playing with the 0 because the 0 is the easiest number in the world. So if you think about this, this is f of 0, which means that you're going to plug in a 0 for the squared. 0 squared, oh my goodness, that was just way too difficult. Okay, let's go over to the positive ones now. F of 1 means 1 squared, which in fact, yes, is 1. So far it's been pretty boring. But now, here's where the fun starts. F of 2 means 2 squared, which means this is now 4. Okay, f of 3, which means 3 squared, which is now 9. Okay, look at this one. F of -1, same idea. -1, don't forget that you have to have brackets around this because you're squaring not just the 1, but you're squaring the -1 as well. So -1 times -1 is in fact 1. Look how these guys are the same. Interesting. Okay, let's go to f of -2. This is -2 squared, which is 4. Look at that. Those guys match. Look at f of -3, which is 9, because it's -3 times -3 is 9. Those all match. So this is going to give us a very, very interesting looking diagram. Let's draw it. Okay, so start with the f of 0. Let's start that because that's a nice point to start with. And let's start going this way. So I have 1 here, 2, 3 in my x, okay? 1 here, 2, 3, those are my negatives, okay? So 1, 2, 3, -1, -2, -3, and let's start plotting. 0, 0, there it is. 1, 1, okay. 2, 4, well, that's 1, 2, 3, 4. 2, 4 is right here. 3, 9, 3, 5, 6, 7, 8. Oh my goodness, look at that. Isn't that interesting? Now let's go back to this one here. -1, 1, -2, 4. Isn't that interesting how this, look at that. Let's draw this diagram out. Here we go. It comes down like this, goes through there, comes up like that, And oh my goodness, what a pretty diagram. This is called a parabola. That's called a parabola, and it's nice and curved, and it's a beautiful U-shaped looking diagram. But I want to show you some really cool stuff on this. That guy here is going to have a specific name. Well, I'll give you a hint. It starts with a V and rhymes with vertex. It's a vertex, you betcha. Now, look at the other things I want to point out to this. Look at this. You've got one on this side, which is away from here. You got one on this side, which is away one. Look how these guys are distance of the same apart. Look how these guys are the same distance apart as well. Look how these guys are the distance apart here. And it seems like this line right down through the center is the dividing line for all of this, which is just absolutely wild. Well, that's going to bring up a whole neat issue coming up right away, and all kinds of different labels that we're going to talk about. All right, so let's get going. Let's go to that page. Here it is. Nice summary of what we've done so far. Number one, what is the quadratic function? It's an f of x that has a degree of 2. For example, x squared. Notice it's got to have the square in it. Second thing, it makes a parabola. And a parabola, remember? We had a point over here, we have a point over here, we had a point over here, and they kind of all match. We call that symmetrical. So this is a symmetrical curve. So in other words, what you get on this side is the same of what you get on that side. We also have something at the bottom here, which is called a vertex, which is the lowest point on the graph. If you think about it, that's as low as you can go. But what happens if this guy is flipped the other way? What if it's this? Okay, the cool thing is then that is called a maximum. That's the highest point it can go. So we can have a low here, which we call a minimum, or we can have a high here, which we call a max. Isn't that interesting? So it all depends on which way the parabola is showing. So I want to show you some more stuff here. Watch this. This is really neat. Here's two different parabolas, and I just want to label the vertex. Remember, when labeling the vertex, it's an XY coordinate, and that's going to be incredibly important to us when we get going on this a little later on. So if you look, 1, 2, 3, 4, 1, 2, 3. That is 4, 3. Noticing that this is going downwards, it's going to be a maximum. Check out this other one over here. 1, 2, 3, 4. That's -4 down 1, 2, 3, -3. And that's actually going to be a minimum value. And what we're going to do over the course of the next little while here is we're going to explore these things, and we're going to talk about them an awful lot. So this becomes extremely important when we get into this. And well, let's hold on to that until the next podcast.